Hello everyone, I am Ms.M.Angelin Ponrani and I am going to handle digital electronics. So in today's class we are going to see about K-map, which is one of the most common methods to reduce any logical expression. Okay, so this is K-map. And this K-map is also called as Karnaugh map. So generally to reduce any logical expression, so far we have used Boolean algebra. So from this time we are going to reduce that particular logical expression with your K-map. Okay. So there are 2 variable K-map, 3 variable K-map and 4 variable K-map. So in this lecture I am going to start with 3 variable K-map. So for example, if we are taking the values A, B and C, you know that the total number of combinations will be 8 based on the formula 2 power n. So here you are having 3 variables. So this n represents your number of variables. So 2 power 3 is your variable and this is 8 combinations. Okay. So let's take one example. So f of a comma b comma c is equal to summation of m 1, 3, 5 and 7. So you all know that this f is a function which having variables a, b and c, and this is summation m. This m represents your main term. So since these is 3 variable, I am going to follow a 3 variable K-map. So this will be your 3 variable K-map. Okay. So before proceeding with this sum, so let's see what are all the conditions we have to follow in this K-map. So this K-map, so if we need a 3 variable, that should be of 8 combination. If it is a 16, if it is 4 variable, it should be 16-bit combination. So while grouping, you have to go with a maximum number of combinations. For example, you should prefer 16-bit grouping, 8-bit, 4, 2 and then 1. So always you have to check for the maximum grouping first. Following that, you can go up to 1. This is the first condition. And the second condition is, while writing any general truth table, for example, if I am taking an AND gate, so A, B is your input variable and Y is your output. So these are 2 variables, so I will be having 4 combinations, which is 0, 0, 0, 1, 1, 1 and 1, 0. So since it is AND gate, this is a dot product, so 0, 0, 1 and 0. Okay. So generally, as like the same, so we have to write this. So always you have to take from MSB bit followed by your LSB. So in this side, I am going to write the MSB, which is A, and on the other side, which will be B and C. So since it is single variable, this variable consists of only 2 bits, which is 0 and 1. So this is 2 variable, so 0, 0, 0, 1, 1, 1 and 1, 0. So in general, we will be writing these combination as 0, 0, 0, 1, 1, 0 and 1, 1. But here I am writing 1, 1. This is because always there should be a single bit change. So if I am writing 1, 0 after this 0, 1, this 0 bit is changing to 1 and 1 is changing to 0 at the same time. This should not happen. So to make a single bit change while writing these 2 combinations, I am writing 0, 0, 0, 1, 1, 1 and 1, 0. So for your simplicity, you can write your min-term decimal number in the corners of your each cell. So this value will start with 0, this is 1. I have to mention 2 here because this is 1, 0 and 1. This is 3, again 4, 5, 6 and 7. Okay. So now I have to write 1 since this is min-term to all the variables which is given in the question. Okay, so for 1 I should do it here, and for 3 I am mentioning 1 here, and for 5 and for 7. So for this K-map representation, the maximum number of groupings starts with 8. So I have to check whether I can make a 8-bit grouping here. That is not possible here. So I am going with 4-bit grouping. So here 4-bit grouping is 1, 1 and 1, 1. So this is my group number 1. Okay. So now how I should write the expression for this. So for this group 1, you have to check your corresponding rows and check your corresponding columns. So say for example, I am taking the variable A, B and C. So for your corresponding rows, the values are 0, 1 and in your column, the values are 0, 1 and 1, 1. Okay. So here it is in the complemented form, so there will not be any values over here, and here also complemented, I will not take it. I will take the final combination C. So my final expression F will be equal to C. Okay, so this is the minimized K-map expression for your given term. Okay, so we'll see another example. So f of a comma b comma c is equal to summation of m 0, 1, 2, 4 and 7. Okay. So this is also a three variable K-map. So I am writing a 3 variable K-map here. So here is your A, this is B and C. So always your MSB should come here and MSB should come here. So this is a single variable, so the values are 0 and 1. For your B and C, the corresponding values are 0, 0, 0, 1, 1, 1 and 1, 0. So for our simplicity, we are writing the min terms on the corner of each cell. So this is 0, 1, 2, 3, 4, 5, 6 and 7. Okay. So now I have to mark 1 for the values which is given here. So this is 0, 1, 2, 4 and 7. Okay. So now I have to check for the maximum number of combination, which is 8, 4, 2 and 1. So here 8 combination is not possible. So I am going for 4-bit combination, that is also not possible here. I am going to go with 2-bit combination. So this is my group number 1. Okay. And this is my group number 2. So here and here, this is my group number 3. And this is one individual bit. I have to take it as an individual one. Okay. So this is my group number 1. This is group number 2. This is group number 3 and this is 4. Okay, so as like we did for the previous example, I have to write the expression for your group 1, group 2, 3 and 4. So for your group 1, the corresponding values are 1, 1. The values in the rows is 0, 1, which is for your A variable. The corresponding column is 0, 0. So 0, 0. Both are complement, it will get cancelled each other. So you have to write the remaining expression. So F is equal to B complement, C complement plus. I am going to take the group 2. So when considering the rows, the value is 0. While considering the columns, it is 0, 0, 0, 1. So 0, 0, 0, 1. So this expression will be A complement, B complement. Since B, C get cancelled with each other. And the third group is this one and this one. So the corresponding row is 0, corresponding column is 0, 0, 1, 0. So this is complement. So A and C complement will be there. So this is plus A complement, C complement. And the final fourth one, which cannot be grouped with anything else. So I am writing it as it is. So the corresponding row is 1, which represents A, and the corresponding column is B and C. So this is A, B, C. So this is your final expression for your example. Okay. So next thing is we are going to see a 4-bit 4-variable key map. So let's take an example. So f of A, B, C and D. So is equal to summation of m 0, 2, 3, 7, 11, 13, 14 and 15. So as you all know, here it is 4 variable. So this will be having 2 power n. So n is your number of variables. So 2 power 4 means 16 combination you should have. So you have to draw a K map that accommodates 16 variables. So I am drawing a K map which consists of 16 cells. So always we start with MSB. This one is LSB. So here it is AB and this is CB. So when considering these two, these are 2-bit variables. So 2-bit variables will have 4 combinations. So 0, 0, 0, 1, 1, 1 and 1, 0. And here also the values are 0, 0, 0, 1, 1, 1 and 1, 0. So for my simplicity, I am going to use min term in the corners of each cells. So 0, 1, 2, 3, 4, 5, 6 and 7. So 8 I should start here because this value is 1, 0. So this is 8, 9, 10, 11, 12, 13, 14 and 15. So now I have to mark 1 for the values which is given in the question. Okay, so for 0 the value is 1, for 2 the value is 1, for 3, 7, 11, 13, 14 and 15. Okay. Next, when coming to grouping, so this is 16-bit combination. So I have to check for the maximum of 16 and then 8, 4, 2, 1, 2. Okay. So here 16-bit combination is not possible. I am going to check for 8 bits. So 8 is also not possible. Then I am going to check for 4 bits. So here is one group. So this is group number 1. And the next one is right from here and here. So this is group number 2. Okay. So here this is group number 3. And here this will be your group number 4. Okay. So now I have to write the expression based on this. So f is equal to, so this is the first combination. So all values will cancel to each other. And here the remaining values are C and D. So this is C, B plus. So here for your group number 2, the corresponding values, while considering the rows, the value is 0, 0, and while considering the columns, it is 0, 0, 1, 0. So this is your A, B, C and D. So this is complement to each other. So we will be neglecting this one. So the remaining values will be A complement, B complement and D complement. This is for your group 2. And for your group 3, so these are the 2 combinations. The corresponding row is 1, 1. The corresponding columns are 0, 1, 1, 1. So these 2 are complement to each other. So I am cancelling this. The remaining values will be A, B and C. And finally this is your 4th group. So for 4th group the values will be A, B. And while considering the columns, the values are 1, 1, 1, 0. This will get cancelled to each other and the final value will be A, B, C. So this is your minimized expression of your given 4-bit value. Okay. We'll proceed with another sum. example 2. The sum is f of a comma b comma c comma d is equal to summation of m 0, 2, 3, 5, 7, 8, 10, 11, 14 and 15. Okay. So again this is your 4 variable K map. So it should have 16 combinations. I am drawing my K map. So it should contain 16 cells. And always remember that you should start with MSB. So here the MSB values are A and B, LSB values are C and D. So again two variables, so it should have 4 combinations. So 0, 0, 0, 1, 1, 1 and 1, 0, 0, 0, 0, 1, 1, 1 and 1, 0. So now I am writing the min terms in the corners of each cell, which is 0, 1, 2 and 3, 4, 5, 6, 7, 8, 9, 10 and 11, 12, 13, 14 and 15. So you have to mark 1 for the corresponding values here. So this is 0, 2, 3, 5, 7, 8, 10, 11, 14 and 15. Okay. So now I have to check for the 16-bit combination 8, 4, 2 and 1. Okay. So this is my 4-bit combination. This is my group number 1. Again this is my another 4-bit combination, which is group number 2. So this is my group number 3. And finally there is one single bit, so I am grouping it all along. Okay. So for your first grouping, the value will be f is equal to, so since all the values are marked here, the corresponding rows will be 0 and the corresponding columns is C, D plus. So for these two, the corresponding rows is these values 1 and 0 get cancelled each other, so this is A. And for 1, 1, 1, 0, this B value gets cancelled, so C value is remaining, so A is C. And for your third group, so your corresponding column values are A complement, B complement, and corresponding column values 0, 0, 1, 0. So C is a complemented version, so this will cancel and B complement will be there. And finally the fourth group is this one, so the corresponding values are A complement, B, and on your columns it is C complement, D. So this is your minimized expression for the given problem. So next thing we are going to see is don't care condition. Okay. So in K map we have don't care condition. Okay. So this don't care can be represented as either D or X. So generally in question they will be giving it as summation of D, and in K map we will be using X. Okay. So this X value can be considered as 1 for your sum of products, and this X value can be considered as 0 for your product of sum. Okay. So while considering this don't care, for grouping, if a particular value is needed to make it as a whole combination, then we have to go for X of X is equal to 1, or else for POS X is 0. Okay. So let's take an example, we'll come to understand about it. So this is example 1. F of A comma B comma C comma D, which will be equal to summation of M (1, 3, 7, 11, 15), and the don't care values will be 0, 2 and 5. So as like your normal schema, you have to put 16-bit combination since this is a 4-bit variable, and we have to do a schema normal method till this. Okay. So for your don't care condition, we will proceed next. So let's put a schema first. So this is a 4-variable schema. So we should have 16 combinations. So this is A, B, and it should be started with MSB, and here this is C. Okay. So 4-bit combinations are 0, 0, 0, 1, 1, 1, 1, 0, and again here also 0, 0, 0, 1, 1, 1, and 1, 0. Okay. So you have to represent the min terms. The min terms are 0, 1, 2, and 3, 4, 5, 6, and 7, 8, I'm sorry, here it is 8, 9, 10, and 11, 12, 13, 14, and 15. So for your 1, you have to mark 1 here, and for 3, for 7, for 11, and for 15. Okay. So you have marked these things which we have seen already, and the extra thing is don't care. So this don't care should be represented with X for your values 0, 2, and 5. So for 0 you have to mark X, for 2 you have to mark X, and for 5 you should mark with X. Okay. So you can consider this X as 1 when it is for sum of products, and this X should be 0 for product of sums. Okay. So I am going to group this. So F should be equal to, so I will neglect all these numbers, only I will be taking the rows, so taking the columns which is C, D, and I am going to group this one. So I am considering this X values as 1. Okay. So the corresponding expression is 0, 0. So it is A complement, B complement. And remaining there is no value. So this will be the final expression for your problem. Okay. So in case if this M is represented as capital M, then you should go for POS method. And another terminology is summation M represents SOP. When it is POS, you have to see that it is marked as pi M, or in general they will be writing pi. Okay. So in that case, instead of X, you should mark 0 and then proceed with the same steps. Okay, we will try to proceed the same steps with the same values for your POS. So f of A, B, C, and D. So this is your pi M, or you can take it as pi. Okay. So since this is pi M, so this M represents max term, and this pi represents your POS. Okay. So when it is product of sum for the given values, you should mark 0 and instead of 1. Okay. And for X, it should be considered as 0. So I am going with the K map. So this should have 4 variables. So 0, 0, 1, 1, 1, 0. And again CD have 4 combinations, 0, 1, 1, 1, and 1, 0. I'm writing the main terms for this 0, 1, since it is POS, for the given values, I should mark 0 in the K map. Okay. So for 1 it is 0, for 3 it is 0, for 7 it is 0, for 11 it is 0, and for 15 it is 0. So for don't care, the values are 0, 2 and 5. So 0 is don't care, 2 is don't care, and 5 is don't care. So this H should be considered as 0 when it is for POS. Okay. So now I am going to group this. So this will be my first group, and this will be my second group. Okay. So for this, the expression will be F is equal to, I have made a combination of all these. Yeah, initially I am going to write F dash since this is POS. Okay. So this equation will be CD plus here A complement, B complement, and here all values will cancel. So now this is F dash. So we have to find F for your POS expression. Okay. So for that you have to take a complement of this. So now CD plus A complement, B complement to the whole complement. So now this is resembling like your De Morgan's law. So what is our De Morgan's law? A plus B, the whole complement is equal to A complement dot B complement. So I am going to rewrite this with the help of De Morgan's law. So this will be C complement dot plus B complement. Here I am writing another formula as well. So A dot B, the whole complement is equal to A complement plus B complement. Okay. So now C complement plus B complement dot product of A complement to the complement plus B double complement. So by using the Boolean law of reduction, we know that the double complement value will be equal to the same exact variable. So here C complement plus D complement dot A plus B. So this will be your final POS expression. So F is equal to C complement plus B complement dot A plus B. So which is your product of sum. So let's summarize the things we have seen today. So for your logical expression minimization technique, we have two methods so far. Okay, the first one is Boolean method, which we have seen in yesterday's class, and in today's class we have seen Karnaugh graph for your 3 variable and 4 variable. Okay, so without don't care condition and with don't care condition, we have seen 2 problems. These are the most commonly used minimization techniques. There is one more technique called as Queen-Kleski method, so which is tabulation method. So that method will be used for the variables which is above 6 variables. Okay, so we will be seeing that in next class. So as for today's class, the 3 variable K map and 4 variable K map with the don't care condition is over. I'll give you 2 more problems. You can work it out in your mind. Okay. So the first problem is f of A, B, C, D is equal to summation of m 1, 5, 7, 9, 11, 13, 15. Okay. So this problem you can work it out by yourself, and to solve more problems you can refer digital book by Ms.M.Angelin. Okay. That's all for today's session. Thank you.